That's why they always say, you know, an electron's like a wave. You know, it is because it vibrates, right? If you're an electron, right, and you're moving up and down as you move, like to the right, this is what's going to happen, right? Right? It's not that you're a wave, okay? It's not that you're, you know, you're not a particle anymore. Oh, you're just a big blob. No, you're a blob because the electron's moving fast, okay? You can't see the electron because it's tiny, tiny, tiny. So you just make up stories, okay? Just because something vibrates and makes a wave-type pattern and makes probabilities, you know, because of this, you know what I mean? And it's hard to pin down its position, right? Because it's always vibrating, even though it's going straight, it's also vibrating, you know what I mean? Yeah. But, you know, that doesn't mean that you have to make up stories, all right? And it's just like a light photon going through space. It doesn't, you need energy to not go, space-time is built for everything to move at 186,000 miles per second, okay? And if you have rest energy, then you don't do that. But if you don't have rest energy, you are forced to go 186,000 miles per second, right? There's intrinsic energy, right, from like the 0 point energy, like from the space-time itself, you know what I mean? So all molecules vibrate, okay? And you can see this formula over here, right? Look at this. Everyone knows this. Energy equals 1/2 mass times velocity squared, right? Look at this one here with the kBt. It's almost exactly. See, now this is just if you have three spatial dimensions, you know, freedom to move. You know what I'm saying? Then you'll have 1/2 kBt equals energy. They're very similar. But I want you to notice. Remember we said in the last couple of videos. When Planck, you know, he has his Planck constant, right? 6.626 times 10 to the negative 34 joules. And remember, that was how many joules, right, that every sine wave had. No matter how short or how long that wave was. And when I mean sine wave, I mean just one packet, one sine wave. One going up and down and up and coming back to the same spot. That's one, and you can see I color-coded these down here, right? Every one of these sine waves has a different color, okay? But every one of them gets the same amount of energy. This gets an H amount of energy. This gets an H. This gets an H. Even this black one gets an H. Even this big red one. They all get an H. You know, 6.626 times 10 to the negative 34 joules. Every one of these. Even these long ones, even the short, all of them, okay? Because, and that's what they mean by quantized. So it doesn't mean it's magic, though. Everything is quantized. Okay, I go to the bar, I can't just get, you know, I gotta get a whole drink of alcohol, you know what I mean? If I go to the store, I gotta get a whole dozen of eggs. They're quantized. Everything is quantized. They act like, if you sit there and you're a grown adult, right? Like you've never walked up steps. Steps are quantized, you know. If you think that it's some weird thing that it's so freaky that you've never heard of quantized stuff, even though everything in your life is quantized. So basically this is, you know, there's different kinds of energy, you know what I mean? And this is one of them. This is the heat energy with the kV thing, right? The H thing, that's the energy from the light, you know what I mean? The packets of light. All sine waves get the same energy, just like all molecules have the same energy here when it comes to temperature. Now all we got to do is talk about one last thing, and that's what is actually a black body or thermal radiation. We said the black box, we had a little black box with a hole in it, right? Remember? That was our black body, and you know, because it was black inside and we had it insulated and all that, and a little tiny hole. None of the light can come out, but light can go in to the hole, you know what I mean? And we said that you know, it can only emit light that it caught, you know what I mean? Just like when you hit light onto this board and the electron gets excited and then it goes back down. It can only give you that. It can only jump up so much from the energy you gave it, and when it falls back down, it can only give you the energy back. You know what I mean? That it got. It don't have any other energy. It only got the energy you gave it. you know, to throw photons off. But these fields and that, you know what I mean, when you got your electrons, you know, going around the orbiting and whatever, you know, sometimes they get tilted out of their, you know, they're out of their spot, or they're just vibrating, you know what I mean? And so they kind of get out of their spot and they end up throwing out some photons, right? This is what black body radiation or thermal radiation is. It's just the emission of EM waves or light waves, okay? And the reason why you're doing it, though, is not as much because you're catching photons from other people. It's because the interactions that's going on inside the board, inside with the molecules. You know what I mean? Because of this twisting and turning, and they're constantly being all the parts are vibrating. But this black body, you know, thermal radiation, right? We all have it. All objects have it. Doesn't matter what, as long as you're above the absolute temperature, and even at absolute temperature, these, you know, electrons and protons, they're still vibrating, man. They still have a. That's what they mean by 0 point energy. That even at 0 degrees, the molecules, not you, you'll be dead, but the molecules will still be vibrating a little bit. You know what I mean? And this here, right here, these, you know, those are kinetic. When you see this energy that says joules, right? That means kinetic energy. They're talking about moving energy. Well, you can tell because it says mv squared. And the moving energy, you know what I mean, here with the kBt, that's, you know, they're vibrating. They're vibrating. That's their movement. See, even like me and you, like a mammal or whatever walks around, when you eat food, you know what I mean, and then you chemically, you know, react it with your, you know, your acid in your stomach and whatnot, you're basically converting thermal energy into electromagnetic energy. Okay, the thermal energy is the kinetic, you know, energy of the random movements or the vibrations, you know what I mean, of the atoms and molecules, and it's all matter does that. All the protons and electrons do that. Sometimes they'll, you know, because of these fields, they'll get accelerated. The dipole will oscillate. You know, and this generates, you know, photons, and they throw the photons out. Usually, if you're room temperature and nothing's happening, you know, freaky weird, you're just putting out mostly infrared light. You know what I mean? But you put a whole spectrum out. You know what I mean? Even once in a while, you'll put out a higher, you know, or a really low photon. Just like the boiling water. It's about statistics and probability. You know what I mean? And a black body is just a thing, you know, like we said, a box. It's anything that will absorb all the light and doesn't reflect any of it back. It's so black or whatever. It's like an ideal gas. It doesn't exist. You know what I mean? But we just, or the speed of light. You know what I mean? At sea, you can't do that. You know what I mean? And always remember, you know, it's about I forget what they call it. It's like reciprocity or something. You know, where you scratch my back and I'll scratch yours. Meaning, these things where they're throwing out photons, they're not. It's at equilibrium. You know what I mean? They're never throwing out. If they don't have enough energy to throw out, you know, shorter wavelengths, then they'll throw out longer wavelengths. You know, but it's equal. It's always equal. What goes in goes out. You know what I'm saying? That's all I want to say. So I just want you to remember that, you know, this radiation, everything is vibrating. You know, all the electrons, all the protons are all vibrating, and they get this intrinsic energy, right? This kB times T, right? So many joules per Kelvin. And they get so much energy, you know, per molecule per degree of temperature. You know what I mean? So everything in the universe is constantly throwing out these photons. Even if they're not getting photons, they're always going to be jiggling and jangling. Well, I did like 5 videos of this. Someone told me they wanted me to do it. I hope they watched it. They never do, though.